f160 doesn't mean the focal length is 160. If you put more energy, it's easily burned, so which actually changed the real focal point distance. Hi everyone, welcome to Jelly Talk. In last episode, we talked about the beam quality, the beam molds to the cleaning effects. And in this episode, we're going to talk about the beam path. As laser cleaning machine, it's a complete machine. Apart from the laser source, which is one of the most important part, and the laser come out from the source will be focused, collimated through the beam path. So today we're going to talk about the beam path effects to the laser cleaning. So after laser come out from the source, the laser goes like this, many directions. And first the lens is the collimator. After collimating lens, all the optics beam will become very parallel. And then this is the reflector lens, which holding by a scanner, normally in laser cleaning applications. Well, in laser cutting or welding, those applications, you need a very small beam and you need high density of the in the focal lens. Then you don't need this reflector because it's always stable there. For laser marking or cleaning, you need to move really fast for the beam. So the laser beam will go through this reflector lens. And after that, the last piece is the focus lens or the field lens. So today we're going to compare the difference between focus lens and field lens and different size of field lens, the difference between them. So the difference between focus lens and field lens, very easily we can see that the focus lens, the laser beam focus to a very small point, like I said before. So for cutting welding applications, you need the very high density of the beam, very small beam size, you use focus lens. Well, when we're using the scanner to move the laser beam to a large field, well, we call it field lenses because besides focus, we had a lot of two pieces of optics to make the laser focus in a field. Well, no matter in the center or in the corner, to have equal beam quality. So we call it the field lens. For focal lens, we have different size. We name it with the focal lens. Normally, if you generally for pulse laser, we use a field lens. For CW laser, we use focus lens. Why? Because for CW laser, mainly used for rust removal, and rust is very easy to be removed. So you don't need to guarantee the equal quality on the whole surface. So you can use a cheaper way to do it with focal lens, and normally it's more portable, smaller. So the size for different lenses, for the focal, we name it f300 means the focal length is the 300 millimeter, or maximum you will go 800 millimeter with very long focus. And for field lens, we normally have the number you got in your hand. It's like this one is very ordinary one is f254, or smaller 160, or bigger 330. So we're going to talk about the difference between different focal lengths. For the focal length, we explained that for focus, it's very easy. You just see the focal length is 300 and it's 300, but for field lens, it's quite complicated. When we call it f160, doesn't mean the focal length is 160. Actually, you got 194, which means the real focal point is 194 millimeter from the lens to the surface. Why it becomes this is because that for field lens, apart from the focal, this is the real focal for the focus lens inside, but we add another two pieces of optics, so which actually changed the real focal point distance. And in this distance, the focal point, you got the focus, the beam diameter at 0.16 millimeter. And for the field lens f254, the focal distance is 294, and the diameter of the beam is 0.24. I put another number here for this is because for the smallest field length in the focal points, I think I explained last episode that all the focal point is not theoretically a point, but it's a distance. Like we focus the beam, and there is a point, but actually it's not the point. It's like this. There's a distance. We call it the beam width, the focal width. So the width here is smaller, and for larger beam, and you got a little bigger width, and this one is even bigger. So this will affect the cleaning effects. After we will show in when you cleaning different materials. First we show the aluminum alloy, because aluminum alloy is very difficult to clean. It needs very high density, high power. And then we will compare them in the wood also, because wood is also very critical for laser cleaning. If you put more energy, it's easily burned. And if you don't have enough energy, it doesn't clean the paint. So, for example, on these two materials, I think it's a very good way to show that how these different field lengths working in that. Okay, so first we see the difference of all these field lengths cleaning in aluminium, because aluminium is very difficult to clean. For this, we use the smallest field length, f160, and the focal distance is, and this beam is very small, so the density is very high. In the center is almost about 2,700 watts in the center. So you see the cleaning surface is a little bit over cleaned or a little bit slightly darkened, and it's a little bit hard on the base material. When we switch to F254, you get very shiny cleaning effects. You take off the oxidation layers and all the aluminum base material disclosed, so it looks very nice. And this, we have this, the largest one, focal 330. You see that because the beam is very big and the center of the beam, the dispersion of the density is very small, less than 1,000 watt, so cannot take off the oxidation. Now we talk about the difference of different sizes of the field lengths from cleaning wood. First we try with the F160, and you will see that because it's too much density on the power, and it's a little bit overburned, a little bit carbonized for the wood. And then you can switch to F330, which we think is very nice size for cleaning wood. You get very equal cleaning effects, because for wood you need very gentle working of the laser on the wood, while this 330 you got very large beam, and then you can have very gentle effects on the wood. So here we comes for the scientific explanation for the theory. First, we name the definition. We call it 80% of the power as the full beam size, and the 70% of the power we call it the core area, which in the picture is the red and yellow. And for the rest, we call it the outer part of the beam. For the power of the laser source as the 300 watt laser source, the energy distribution goes like this in the chart. So from that chart, we got the energy distribution curve as in the picture. We will find that the larger of the field length, the focal length, the larger beam you will get in a focal point. And the larger of the field length, focal length, the less, because a larger beam, which means that the power density is smaller. And especially in the core area, the power density dramatically lowered. So that's why we switched to field length f330. We cannot clean the oxidations of the aluminium. And if the field length, focal length are bigger, the energy distribution in the full beam size is very equal. So the difference is it become much smaller, which we call it from the core area to the main area and to the outer. And so you get very equal cleaning quality. That's why when we switch to the long focus f330, when we clean the wood, we got very equal effects. Okay, so that's all about today. And in the next episode, we're going to go deeper, because now we have new version of long destructive cleaning. I think we've launched it last year. These effections that mainly focus on the stainless steel cleaning after welding. Many customers feedback to us that even with long destructive cleaning, you still see the color difference after cleaning. Well, some customer doesn't accept this. So we keep working on this, and now we're coming up with new version of the long destructive. We minimize the effects on the surface of stainless steel, and our engineer will bring us the deeper insight on this technology. So stay tuned. We're coming up with new technologies next time. See you.